masses of ocean water that flow from one place to another. What do you mean by masses of water? It means they have some particular characteristics. Like in ocean water, what are the characteristics? Salinity, temperature and density. The mass of water which has similar salinity or temperature or density, that we call as a mass of water. So if a mass of water having similar characteristics, they flow from one place to another in a particular direction, that we call as a ocean current. That means the water mass may be small or may be large. It depends on the different phenomena. What are the driver of ocean current? Okay. What does that transfer? Basically, first of all we tell that it is basically similar characteristics of temperature and salinity. But besides that, if we have difference in temperature, then water from what happens? High temperature water comes to colder temperature of water. So to distribute the heat, basically that what current transfer heat from warmer to
colder areas.
On Earth, just as the wind does. How wind pattern occur? Like general circulation of atmosphere. Basically, what happens in equator? Due to direct sunlight, what happens? Heat occurs. Then what happens? Low pressure creates. From low pressure to wind travel from low pressure to high pressure. Similarly, according to wind, like that of wind, ocean current also can travel from equator to pole, then pole to again equator. So this is a circulation that is called as ocean circulation. Basically, what happens? Wind will transfer 2/3 of the energy, heat energy. Rest 1/3 heat energy is derived by ocean current. So this is a pictorial representation of wind and ocean current. See, this is what we call it. This one, trade wind. Have you ever heard about trade wind?
No, sir. No.
Northeast, southwest, northeast and southeast. Trade wind. In equator, what happens? Low pressure creates. Before 30 degree and 60 degree, there is high pressure zone. So from high pressure to low pressure, wind should be flow. So because of what happens? Because of Coriolis flows, it deflects towards right in the northern hemisphere and left in the southern hemisphere. That we call as trade wind. See this one, this blue or sky blue. This is trade wind. This is trade wind. So according to from here to here, trade wind flow. Because of that, the water masses travel up as the path of the wind. See, this figure and the blue color, they are flowing in the same direction. So, because of the trade wind, what happens? The energy transfer from the wind to the ocean and the water mass flow in the direction of the wind. So, basically, because of this, what happens? The water mass flow from here to equator to, it should be parallel to the wind. But what happens? Because of the continent, it cannot circumference the earth. Because of the land mass, what happens? It travels towards the north. See here, the trade wind was what? It's always in the same direction. Because what happens? The atmosphere is above the land, so there is no obstruction. But in ocean, we have land masses. So because of that, it cannot cross the continent. So what happens? When the wind transport the energy and the current will flow from here to here, because of land mass, what happens? It deviated towards north. Okay, north. Then according to the westerlies, this is called as westerlies. See, equator, then 30 degree, 60 degree, then 90 degree.
Pole.
So what happened here? Equator is low pressure, then high pressure, then again low pressure will create. So from what happened? There will be another wind another wind which is called as westerlies. Okay, due to trade wind, what happened from east to west current flow. Then because of continent, what happened? The current flow towards the north. Then because of this wind, westerlies, what happened? It deflect towards again east. And here again it, because of the landmass, it again goes down. So basically it completed one cycle. So this is called as gyre, ocean gyre. Okay. Similarly, like that we have how many oceans?
5.
5. So each ocean have similar kind of gyres. See, this is Atlantic Ocean. This is North Atlantic Ocean. This is
South Atlantic Ocean.
So in both hemispheres, because of what? Coriolis force, it see here it is circulating clockwise direction, but here it is
Anti-clockwise.
direction. Similarly, in Pacific Ocean there should be two gyres, clockwise, anti-clockwise. In Indian Ocean, what happened?
Only anti-clock.
Here two. In Pacific there is also two, but Indian Ocean.
Anti-clock only.
In Indian Ocean, in northern part, India is in the middle of the ocean. You have remembered how Indian map is. See here. In Atlantic and Pacific there is no land mass in the northern. So there is always two gyres to be formed. But in Indian Ocean, what happens? There is a land mass in between the ocean. Okay. So the circulation pattern in the Indian Ocean is different.
Anti-clockwise.
Different. It is different. Okay. And but Southern Ocean, in Southern Indian Ocean, there is no land mass. So there should be one gyre. But for Indian Ocean, it is something different. In addition to that, there is monsoon also be there. So because of monsoon also, the circulation pattern will be different. Okay. So because of this atmospheric wind belt, we have different kind of gyres will form. So each ocean have two gyres. And the middle of the gyre will be fall on 30 degree to 60 degree. Okay. Because of that, the gyre is named as subtropical gyre. Okay. Why we call it as subtropical gyre? All these gyres. Because the center part is fall on 30 to 60 degree. So how many gyres we have in the world ocean?
5.
1, 2, 3, 4 and 5. 5 gyres.
Ma'am, what about Arctic?
Arctic there is polar gyre. This is all about
Subtropical gyre.
Okay. In polar there will be another gyre. Okay. So see, the water masses in Atlantic Indian Ocean is very small in volume. But in Pacific it is a larger area. So to complete a one circle in Atlantic Ocean, it will take about 3 years. But because of this larger area, Pacific Ocean gyre, it will take around 6 years. Okay. So in this figure, you can figure out these are the current. Okay. So black, there are 3 colors.
Black, red, blue.
Black, red, and blue. So basically, the black, wherever there is a black color is there, it is going in the same direction. See, in the equator, these are all equatorial current. Okay. The equatorial current always flow from east to west. See, these are called equatorial current, not middle one. Above this. This is equatorial current. This is north equatorial current. This is south equatorial current. Similarly, in each gyre, there is 1, 2 equatorial current, north equatorial and south equatorial. trade
Hmm.
wind. Trade wind is always in flow in the same direction. So does the equatorial current. They never change the direction. Okay. What happened? The trade wind is always in the same direction and the Coriolis force is also zero in the equator. So what happened? The whatever the water masses from east to west, they will flow. But because the Coriolis force is zero, they can deflect anywhere. Okay. But pile up in the western side. Here. Okay. The north equatorial current take the water masses and flow towards the western part. But here water will pile up. So they can't move north or south direction. So where does they move? How does they move? If they can go up north or south direction, they will move under the ocean. Okay, under the ocean. So, or in the same direction. Okay, so it is called as equatorial counter current. See, this direction is different from the equatorial current. This one, equatorial counter current. Here is also equatorial counter current. Here is also equatorial counter current. Okay, so this is clear, right? Northern equatorial counter current, southern equatorial counter current, then equatorial
Counter.
current. Why does it is called as equatorial counter current? Because it is flow in the
Opposite direction of the.
direction. So basically, what happens is this equatorial currents are warmer in nature. Okay, so warmer ocean current flow in the western part of the basin. This is called as western part of the basin, but in the eastern side of this continent. Okay, western part of the basin. See, here it is North America, South America. So this is east part of the continent. But what happened? If we consider the basin, it will be the west part of the basin. So it is called as western current. Okay. If we look at very closely to what happened in each western part, you will find a red color current. See, this is Gulf Stream, then Eurosio, then Aguilas. These are all western part of the ocean basin. So this why it is called as red color, because they carry the warm water from the equator, then flow alongside of the western basin, then goes towards the polar region. So they always carry the warm water. Okay, this is called as western currents. So you have to remember that every western current is warmer in the nature. What happened after they take the equatorial water masses, then in the polar region they should release the heat. Okay, if they release the heat, what happened? They will cool down. So next what happened? Because of the westerlies, you remember this figure. This is westerlies wind. Because of this westerly wind, what happened? That water mass is reached to this region. Then they deflect towards the east side. Okay. So what happened? If they transport from here to here, they release the One is Ekman spiral or Ekman transport, geostrophic current, and western intensification of subtropical gyres. Ekman transport. What happened? First of all, we said that if wind blow along with the wind, what happened? Water masses also flow. But it's not the case. What happened? If wind flow from one direction, then the water masses will travel at 45 or 90 degree angle to the right in the northern hemisphere and left in the southern hemisphere. Why does this happen? Because of the Coriolis force. See, if in equator what happens? There is no Coriolis force. So the water masses travel along with the wind. But as we move from equator to pole, the Coriolis force increases. Right? So because of that, what happens? The water masses cannot move alongside of the wind. It should be deflected towards right in the northern hemisphere and left in the southern hemisphere. So this is a pictorial representation. See, this is wind. So wind and this is a shape. So what happens if the shape don't have any its own motion? It will be very still. So what happens if wind blow in this direction? The shape will deflect it towards right. See, this iceberg is also deflected towards right. And Ekman spiral. What happened? Because of Coriolis force, the water masses would deflect towards right in the northern hemisphere. We will consider only northern hemisphere. So what happened? Coriolis force. Another force is frictional force. The frictional force drags the what? It will decrease the motion of the any body. Okay. So what happened? Because of Coriolis force, water mass deflects towards right. As we move towards down, what happened? The Coriolis effect increases. Okay. And frictional force decreases. What happened? Because of that, if it is deflected towards 45 degree, then the deflection increases as we move down. See in this picture. Here the surface current is 45 degree. Then it will be increases to 50 degree. Then 60 degree, 70. Then after some depth, it will be just opposite of the surface current. So if we integrate this part, we will be found the water mass transported because of the wind. So basically, Ekman spiral describes about how the Coriolis force and frictional force affect the ocean current and how. See, there will be some certain depth up to which the wind transport its energy. It can affect up to depth 1000 2000 meter. So to describe that mechanism, Ekman spiral is introduced. Okay. So then geostrophic current. See in this picture what happened? Subtropical gyres are present. Okay. And we studied that because of Coriolis effect, what happened? Water masses should deflect towards right in the northern hemisphere. If we consider any gyre, see here. So what happened? It will deflect towards right in this gyre. It deflect towards right. It deflect towards right. It also deflect towards right. It also deflect towards right. So what happened? If every water mass is deflect towards right, then what happened? At the center, water will pile up. Understood? If each current in this circle deflect their water masses towards the center, so water masses will pile up at the center. So what happens? There will be one bulge of ocean water. So what? Because of the gravity, this bulge wants to deflect towards downward. If water will be at higher position, what is the properties of water?
high concentration to low concentration.
higher, not at a height, from height to downward, it always
Up, downwards.
downwards. So because what we call, because which factor? Because of gravity.
Gravity.
Water will fall downward. So because of Coriolis force, what happens? The water pile up at the center. So gravity wants to pull down the water from the center towards outward. But because of Coriolis force, what happened? They are again they deflect towards the center. So there will be one balance between what? Gravitational force and Coriolis force. So this balance is called as geostrophic current. To maintain this balance, they will flow in the circular direction. Okay. So basically, geostrophic current is called as the balance between gravitational and Coriolis force. Besides gravitational, we can consider as pressure gradient force. What happened? Because of this difference in water masses, height of the water masses, pressure gradient will create. So the current which travel in balance between pressure gradient force and Coriolis force, that is called as geostrophic current. But what happened? Because of this geostrophic current, the water mass could not pile up exactly at the center. They are deflected towards the western part. See here. Okay. So if they will be produced exactly at the center, the circle will be complete one. Okay. The water mass should the velocity of the water mass is always same throughout the circulation, but because of the geostrophic current, what happened? The water mass pile up towards west side. So what happened? And this is one point. Okay, the center is shifted towards western side, and in the from equator to pole, the Coriolis force is increases. From equator to pole, it is increases. From pole to equator,
Decreases.
it is decreases. So here the water masses pile up in the equator. Okay. Again, because of the increase in Coriolis force with respect to latitude, what happened? They deflect more amount of water. Okay. So what happened? And here what happened? Because the Coriolis force decreases, the same amount of water deflect less. Okay. So this, the larger amount of water mass, what happened? Get a smaller area. In this picture, see. Here, what happened? Because if the center is here, then they will get the larger area. And because the area is small, what happened? The same amount of water masses get a smaller path. Whereas here, what happened? The same amount of water mass get a larger area to flow. If the same area, same amount of water masses flow in this small pipe, what happens? The speed will increases. If we have larger amount, larger pipe, what happens? The velocity will decreases. Same phenomena. Okay. Here it is a narrow path. So the water mass is not changing. The same amount of water mass, whatever here in the equator, they transfer in the western side, then again in the northern, then again in the equator. But here the same amount of water mass get a smaller area, here it get the larger area. So what happened here? Whatever the western boundary current, they get the smaller area. So their speed increases. Whereas eastern boundary current, their speed decreases. And the depth, if they are getting smaller area, the depth of the current increases. Okay, but in the eastern boundary current, what happens? The depth is less. So in the one factor is in the western boundary current, it will carry warm water, narrow area, and high speed. Okay, deeper depth of the current is also high. But whereas in the eastern boundary current, what happened? Cooler water, slower shallow. Shallow means less depth. Okay, so shallow water will, shallow current will flow in the eastern boundary current. Okay. So this is called as western intensification. And these are the characteristics. See, what are the western boundary current and eastern boundary current from this figure? What are the western boundary current? What are the western boundary current? Name. This is Gulf Stream.
Gulf Stream.
What is the peculiar thing of Gulf Stream? It is the strongest current in the world. But now studies is found that its peak decreases due to climate change and other things. Okay. So this is the Gulf Stream. Okay. In Indian Ocean, Agulhas current. This is called as Agulhas current. Okay. And this is Brazil current. Okay. Then Euroseo, East Australian current. These are called as western boundary current. Okay. Then eastern boundary current, California, Canary, Peru, Western Australia. These are the eastern boundary current. And how the western boundary current and eastern boundary current affect the climate of that particular area, coastal area. If warmer current flow, then what happens to the coastal area? So there will be more rain will occur. But in colder eastern boundary current, there will be less
Rainfall.
occur. So you can, most of the desert will found in the eastern, alongside of the eastern boundary current. You can check that later. So basically, whatever we studied till now, these are all
Geostrophic.
These are all ocean current because of wind. So these are called as surface circulation or surface water circulation, ocean circulation. There is another circulation is there. What is called that? Thermohaline circulation. Okay.
Surface circulation, surface circulation, or normal ocean circulation difference. Ocean circulation, surface circulation, same.
That is called as ocean circulation is called as surface circulation. But ocean circulation can be two types. One is surface circulation because of wind, and another is thermohaline circulation. Types of circulation. Okay, wind-driven circulation and
Thermohaline circulation.
The wind-driven circulation basically
Surface circulation.
see on the surface, but thermohaline circulation
In the deep.
Deeper
can
sea.
be up to deep part of the ocean. Okay. This separate thermohaline circulation. Why thermohaline circulation is happened? Thermo means temperature. Haline means
Salinity.
Okay. To maintain the balance between temperature and salinity, thermohaline circulation will
Occur.
occur. And the component of temperature salinity is called as density. Density is the factor which is controlled by salinity and
Temperature.
In polar region, what happens? Because of less temperature, high dense water will form. Whereas in the equator, less temperature and because of rain and all, low dense water will form. So what happens? From high dense water to
Low density.
low density region, the water will flow. To complete that circulation, it is called as thermohaline circulation. See, the wind-driven circulation, wind energy is very high. Okay. So accordingly, the surface currents, velocity of the surface current is also larger amount, like bigger amount. But what happens? Thermohaline circulation is very the speed of thermohaline circulation is very less. So it is 1 centimeter
Per second.
Okay, it will take lot of like many years to complete one circulation. But in the gyre, it will take 3 years to complete the circulation. It will take hundreds of years to complete the thermohaline circulation. This is the
Thermohaline.
pictorial representation of
Thermohaline.
circulation. See, wherever there is a in the polar region only deep water will form. And the red color, these are the direction of water in deeper region. Okay, it will flow in the deeper region of the ocean, whereas in the
Blue color,
it will come to the surface. Okay. Here high depth water will form. It will go like this, like this, like this, like this. Then one upwelling region will be there. That water comes up. Then again move in the surface direction in the surface water. Then again deep water will create. Then again it goes down. Similarly, the water thermohaline circulation will complete. Right. So these are all the opening regions where the deeper water, here deeper water form, then goes down. Okay, here the surface water come, cool down, then deeper water form. Okay, this is the salinity figure. 32 to
38.
38. So here the salinity is less. Basically, temperature only is one factor which create the deeper water. In the polar region only, the deeper water will form. Okay, it will comes to the equator. Then again, salinity is becoming less. Then they will flow certain path. Then again, it will go to the polar region. The density increases. Then again,